Hello, everyone. My name is Sai Venom, and I'm a developer advocate on the Amazon EKS team. Welcome to another episode in the EKS Workshop series. In this series, we invite experts to talk through specific modules in the EKS Workshop, and we'll actually get hands-on and go through it. Today, I'm joined by Federica Ciuffo. Federica has actually been in AWS for almost 3 years and has been making waves since then. Fun fact, Federica didn't actually study computers or computer science in school. She actually studied mathematics. Federica, can you tell us a little bit about yourself and how you got into your career at AWS?
Yeah, absolutely. Thank you, Sai, for the introduction. I am Federica Ciuffo, and yeah, I've been working at Amazon Web Services for 3 years. So my background, as you said, is I'm one of a mathematician. In fact, I've studied math at uni, and then when I started working, I actually entered in a consulting firm, a center in the cloud area, hands-on from day zero with Terraforms, cloud formations, and things like this. Very in-depth into the automation part. And then, well, I moved to AWS. I've been a journalist SA for 1 year and something. And then I moved to a container specialist solutions architect role. That is my actual role right now. And within the containers area, I do focus in the networking and containers, let's say, area of depth. And yeah, this is where lies also my interest. And this is really strictly related to what we are talking today, actually.
Exactly. So we have Federica on the show today because she was one of the core contributors to EKS Workshop, which is an open source project. And today, I'm pretty excited because Federica is going to walk us through her module and explain a few things about VPC Lattice first. So, hey, how about we get started with that? Tell us a little bit about VPC Lattice before we get hands-on.
Yeah, of course. Let me just spend a few minutes to introduce you to this networking service since it is very new. It has been GA for a few months already. We do have, Sai, if I am correct, some videos which go in depth. So in here, we will be only on high-level overview.
Absolutely. Yeah. If you want to see our dedicated episode on VPC Lattice with Tim Dormer, you can click the link on the top right here. But Federica, let's hear it from you.
Yeah. And well, what is actually Amazon VPC Lattice? First of all, just said that it's a networking service. But it's not the networking service that you are used to, like, for example, Transit Gateway that connects VPC together. In here, we are talking about an application networking service. So it works at the layer 7 of the hosting model. And basically what we did, we embedded layer 7 capabilities within the VPC fabric that you could use to connect applications and not only connect application from the networking point of view, but also manage these applications together based on access needs, security needs, and observability needs. So when we are using this service, which is completely managed by AWS, you get some capabilities which are very much service mesh-like, but it's not only a service mesh-like capability that you have, but also there are some limitations that we have seen with most of the service meshes that are available today that VPC Lattice solves. One of them being, and I've actually written this down in here, that it actually works cross-platform. So it works across EC2, containers, and serverless. And this is really important because when I say that it works across these services, what I mean is that those can be the targets of Amazon VPC Lattice, and you could have a common DNS record name URL that you are, let's say, talking to, and behind the services that are the application that you are hosting could be spread across these services. Another thing that you go beyond with Amazon VPC Lattice really easily are those boundaries that we have usually within Amazon Web Services. That being the networking boundary of the VPC and the security boundary of Amazon accounts. So in reality, what we do is that we give you a new boundary that is the service network. And the service network is a way for you to have these applications grouped together and, again, based on the networking, access, patterns, and observability needs that you have. So the service network then is one of the components. It's the first one that you will be creating. But apart from this, once you have this, let's say, boundary that is a logical boundary in the end, you also need a way to express or define your microservices, your applications. And this would be the service component. So the service represents a customer-owned application unit that basically behind this, there would be your applications. Again, your application could be hosted on containers, on EC2, on serverless, like for example, Lambda. And associated to this, you will be given this DNS record. And this will be your endpoint, which is managed by AWS, managed by Amazon VPC Lattice for you, but it becomes serves in a load balancers-like way this traffic that you have behind this. So you have all the layer 7 capabilities that you would expect, like for example, the capability of specifying a custom DNS name or specifying, I don't know, for example, rules or paths, etc., to your applications. Obviously, these DNS record names are managed by this part of the components, that is the service directory. In fact, the service directory is a registry that Amazon Web Services automatically manage for you as a component of Amazon VPC Lattice. And in fact, when you define the service, we already said that you will be given a DNS name. This is automatically generated by Amazon VPC Lattice and managed by it, even though you can obviously customize it with your DNS names. We also talked about security. And one of the features that you can enable at the service network level, and if you want a finer-grained security at the service level, are security policies. And the great thing about security policies is that those are identity and access management based, and enables you to actually allow or deny the data path and the access to these applications served by Amazon VPC Lattice.
Got it. Got it. So, okay. So one of the questions that I had here, Federica, so when we talk about VPC Lattice, I think, the key is in the term, it's Amazon VPC Lattice. So it's referring to the fact that, all of the services that it manages need to be running within an Amazon VPC. But of course, now that we kind of dive into it and we see things like the service network and service, one of the things I was thinking, this is really reminiscent of Kubernetes, right? I mean, the same idea with a Kubernetes service, which represents, potential application unit as kind of described here, where it can front a number of pods across node 1, node 2, node 3. This is, essentially another layer of abstraction on top of that. So I guess my question is, how does VPC Lattice actually integrate with Amazon EKS?
Yeah, absolutely. And actually, you are really on point because we do have an explanation for that as well. The relation with Kubernetes that we are using from and leveraging from Amazon Web Services aside is the Kubernetes Gateway API. And this might be the first thing that some of the audience has heard about Kubernetes Gateway API. So let me just run through this real quick. This is actually the Kubernetes documentation. So it's not something that we invented. It's a new API or a new set of API that has been created by SIG Network with the aim to standardize the Kubernetes networking and improve with the lesson learned that we have from ingress and service meshes. So, for example, you want to specify something like advanced traffic routing capabilities, an HTTP header, traffic shifting. How do you do that usually right now? You use annotations, you use customer source definitions, and we know actually that those mean different annotations, different customer source definition, depending on the controller that we're using, the ingress controller that we're using. So what we want to do, or at least what SIG Network is aiming for with this project, is to standardize all these things that we know right now that our customers and Kubernetes users need into the Kubernetes API. So that even if we have different implementations from the Kubernetes networking in different environments, etc., still we are relying on a very defined set of APIs which have all the capabilities that we need for advanced networking. And that's basically what the project is about. And we have a number of objects within the project that we can leverage. And actually, we leverage as well as AWS. So just real quick, we have these objects starting from the gateway class. Gives you a way of defining all the set of load balancing implementations that are allowed to be used by the Kubernetes Gateway API. Much like we use, for example, the ingress class, and then we have an ingress controller, and then we have an ingress, but we always need to refer to this ingress class in those objects. Then we have a gateway. The gateway is another object that we create and basically represents the point from where the traffic that goes from outside the cluster is translated to in-cluster traffic. Then from this point, the traffic will flow according to some rules. So those rules are then specified into the HTTP route object. And we will have some targets, obviously. Those targets are the services. Now, the services could be Kubernetes services, but it could also be external endpoints. So this is another great feature of the Kubernetes Gateway API. It's extensible. And another thing that you might have seen here is that we have a clear separation of duties between infrastructure providers, who are the owner of the gateway class. In this case, we are the infrastructure providers. And we have cluster operator, which will be able to have ownership of the gateway. And then we have the application developer, who can really own how the traffic is redirected to their application. Is a really cool thing that we also encounter in Amazon VPC Lattice. Coming back to what you were saying, Sai, is also this is also why we choose this new set of APIs to have this mapping of the roles, organizational roles, to be really the owners of components within the class, and then we'll see how we translate this into Amazon VPC Lattice components. And that's exactly what I have been doing here. Mapping these components to Amazon VPC Lattice components is really important. So that's why I previously explained what each and every component meant. But basically what we created is a controller, much like you have the ingress controller, but a controller for the AWS Gateway, Kubernetes Gateway API. This is called AWS Gateway API controller that automatically picks up changes and events for creation, update, and deletion of these resources, and maps it and creates automatically Amazon VPC Lattice resources. For example, the gateway is mapped to VPC Lattice Service Network. HTTP routes are mapped to VPC Lattice Service. And, well, the services are VPC Lattice target groups. And we will be seeing exactly that, but with an example, obviously. We are on the EKS workshop, so we do have an application that we'll be using, and we will be seeing how we create a data path for this application, and actually going into this module, it will be the traffic management module, but what we will be doing before is to actually install this controller because it's needed to do this kind of translation.
Right. So when you mentioned translation, essentially what the Gateway API controller is translating between the actual VPC Lattice service running in AWS and translating YAML manifest that we pass into the Kubernetes cluster to define networking. So it's kind of connecting the dots between Lattice and Kubernetes resources in the Gateway API, right?
Exactly that. So let's go into this section. We will be getting hands-on from now on. So we'll be switching from here to the terminal a bit. So the first thing that we need to do for deploying the AWS Gateway API controller is actually to change or at least add a rule to the security group of the node group that we have for Amazon EKS. I've actually already done this part, but basically this set of commands is related to adding this security group rule. And then we will have a policy. I already have this created as well because I have a bunch of EKS clusters which are already using this policy in my test environments. But basically, this is a policy that we will be giving to the controller because obviously it needs to operate with Amazon VPC Lattice and have the permissions that are needed for it to create, update, and delete VPC Lattice services, service networks, etc. And actually, just a note here, this is the default policy that we have. But please, if we are using these products to production, do restrict these to relevant resources, etc. So the very first step after these two steps that I already have done will be to create a namespace. This will be the namespace that will be hosting our controller. So once I have created the namespace in here, that is simply called system, we then retrieve the VPC, this IAM policy that the controller will be needing. So here I'm simply exporting the URL because I will need it then to create an IAM role for service account. And we have it. So the service account is named a Gateway API controller. It will be obviously used by our controller. And actually, I go ahead right now and create the controller. We do have public ECR where we have the image hosted, and we will be using Helm to install the controller. So let me just go ahead and run this command into Cloud9. So now we have the controller which is installed. I can review this, and actually, let me just put this in here. Okay, we can review that this has been created in the system namespace. Yep, and so we have two replicas turn up. This will be the piece of application that will be translating my Kubernetes Gateway API objects into Amazon VPC Lattice infrastructure. So this is kind of a central piece that we need.
Of course, we're working with custom resources and custom resource definitions. And for those to actually do something, for them to get read, and for VPC Lattice resources to get created, of course, we needed Ursa to set up the authentication and authorization. And now, of course, the controller itself, which runs that logic of calling the AWS APIs to create the resources that I presume we're about to create.
Yeah, actually, this is all wrapped up into the custom resource definition, the things that you just explained. Those are wrapped up nicely into the Helm. So once you install it, it's all clean installation with all the resources, all the service accounts that you might need for the controller to be working. And so it's not only the deployment for the controller, but we do actually have an official repository if you want to check it out, the AWS Application Network in Kubernetes, where we have the controller and also a few examples on how to use AWS Gateway API controller. And this is also really a really cool thing that I like to point out. The control is open source, so you can go actually check the code and contribute.
Excellent. And we'll have a link to that in the description below. And
the last thing that you need for pre-installation steps that are already made, create the gateway class. As you said before, Sai, this is our part of the ownership. In fact, we already have a gateway class that is ready to use. You just need to apply it, and it will be defined. And if we see and have a look at this gateway class, we can find the familiar name that we expect, Amazon VPC Lattice, and the controller that we just created.
All right, so that's all it is for installation. So now we get into the fun stuff of what exactly can we do with VPC Lattice. I think you explained there was a number of different use cases. It's like a service mesh, And so what's the use case that we've defined here? Let's get into it.
Yes. So in this case, what we did, we use the application that we usually use with Amazon EKS Workshop, but we took a specific microservice, which is the checkout microservice, and we tweaked it a little bit so that we had two versions of the microservice, version 1 and a version 2, which is modified with a Lattice name, obviously to stay in theme. And then what we do, we use all the objects that we have seen before, so the gateway, HTTP routes, etc., to create a path, a data path, and VPC Lattice resources that will automatically redirect the traffic either to version 1 or version 2, enabling you to redistribute the traffic automatically with VPC Lattice, which is completely managed by us. But yeah, let's see what we are doing here. First of all, we will create the new version of the application. As promised, we basically create this in a new namespace. It is checkout v2. So let me check out what we have.
Here we're using kubectl apply -k, passing in a directory. So you'll notice in the entire workshop, we use a tool called Kustomize, basically a way for us to organize the different manifests that we will be deploying Kubernetes and even applying changes to them. We use Kustomize to essentially deploy the exact same version of checkout, but with an updated container pod. So it's going to have the updated v2 version, and we're putting it all in a different namespace. So, okay, it looks like it's created them. And what are we seeing here?
Yeah, so what we do now, we create, first of all, the service network. And if you remember before from the image that I showed you, this maps to Kubernetes Gateway API gateway. So what we need to do actually is to create a gateway. I go ahead and apply the file, but simply the file I'm applying is this one. So we give the gateway a name. We are using the gateway class that we defined. It is Amazon VPC Lattice, obviously. And then we will be using here, for sake of simplicity, HTTP, but you can also use HTTPS and define a gateway that have both HTTP and HTTPS. Once we have created a gateway, so let me show you that we actually have a service network created in the AWS console. And actually, you can check out VPC Lattice components under the VPC section. And being new, it's in the very last part as the day of this episode. And we can see that in the service network, we actually have the EKS Workshop Gateway service network that we have created. The controller doesn't only create the service network, but also associate the VPC where the EKS cluster belongs, so that we know to have this kind of association, and then we can work on going forward with services, etc., etc., etc. So nice to see that we have this.
So one of the things I've noticed here is that there's one VPC association and 0 service association. So technically, this isn't doing anything yet, right?
Yeah, that's correct, because again, this is a new logical boundary. So unless we do associate some services in the backend, some applications, even if we had redirect the traffic to this service network, we don't really have nothing to distribute this traffic to. Let me show you that you can also have these resources and the IRN for this resource via the terminal. In fact, if we describe the resource that we just created, we do have all the information that we can also see, and we did just see into the console. Well, so let's create the routes to the targets. And here, simply what I'm doing before, I'm patching like a component for our checkout service, simply because we don't have support for HTTP, let's say, specification, but for target port. So let's create a service. And if you remember, if we want to create a service, we will create an HTTP route object. So let's check out what we have just created. We have created an HTTP route in the checkout namespace. The traffic goes from the gateway, that is the service network. So there will be some kind of association here. And then you will have some targets. Targets being the checkout services version 1 and version 2. So in namespace checkout and in namespace checkout version 2. The way that we are weighting these is 25/75 for checkout and checkout version 2 respectively. So let's looking at this into the console. We are expecting here some.
There's one service association. There we go. Okay.
Exactly. And this service association will be the one that you are thinking about. So this new service that we created is the one that we have just created with the HTTP route. And we have associated it to the service network that is the EKS workshop gateway, the one that we created before. Again, this shouldn't be any surprise, but it's nice to see that the controller doesn't only create this service, but it also associates it automatically within the service network that you actually are specifying. It doesn't do anything that you wouldn't specify. We did specify this into the parents ref, let's say, specification, which is where you define the gateway that is the service network again, all connected together.
Got it. So now we just have to tell our UI service, which was previously calling checkout. So instead of having it call the checkout service directly, which Kubernetes would resolve to, the checkout service running in the cluster, we now need to have the UI service call the VPC Lattice endpoint instead, and let VPC Lattice resolve using its rules of 25% go to checkout version 1 and 75% go to checkout v2. So how do we do that?
Exactly. Now what we want to do is to have this endpoint that Amazon VPC Lattice has automatically created for us. And how do we have this endpoint? We can see it in this part if we are describing the HTTP route. So Amazon VPC Lattice has actually given this service and associated this service to a DNS name. And what we will do after this is simply we do have actually a command to export this and to patch the config map, as Sai was saying, to redirect the traffic from the UI to the checkout component through Amazon VPC Lattice, this new endpoint that we are using. And the only thing that we'll be doing is just to delete the pod UI, just to ensure that we don't have any caching problem here. And we will port forward just for the sake of simplicity. And all that is left is to check that this is working and that we are serving the traffic through Amazon VPC Lattice. So we can do this by previewing the application in here. And here it is. We have the running application. Just maybe let me, just for the sake of having this a little bit bigger. And we need to go to the checkout part of the application. To do so, we go into cart and checkout. We fill in some things. You can fill in random things here, just for the sake of trying this new feature that we have. Just ensure to have these 5 number cipher. If you don't, the application will tell you, but if you do know it beforehand, it's better.
So we have a 75% chance of it working. Nice. It looks like it worked.
Actually, if we have 75% of the traffic that is redirected to the version 2, and we see right now some a word that has been used quite a while in the past minutes, which is Lattice. Lattice Priority Mail and Lattice Priority Mail Express.
Right.
This is the modified version.
Yeah, and I don't think we explained this. So really quickly, the difference between checkout v1 and checkout v2 is that in this checkout process, we simply change the type of mailing from priority mail. There you go. Okay, so you refreshed a few times and boom, we see it switch back over to priority mail. So 75% chance of it showing Lattice, 25% of showing without Lattice. Makes sense.
Yeah, and that's all. We what we are using to redirect the traffic from the UI to this checkout component, again, is this endpoint that is completely handled by VPC Lattice. So you don't really have to deal with the DNS name changes and things like this because it's a common endpoint. And this could be also a common endpoint for you across different compute options or across clusters. So this is really nice if you think about it because it means that when you have two versions now, having a common endpoint, a common URL, a common DNS name, you don't need to change not only the traffic from one endpoint to the other, but also all the collaterals that you have with this operation. It could be security, could be observability. So we're taking away a lot of effort in doing so. And yes, this is an in-cluster example, but this can be, again, much more and extended to compute options and cross-cluster. We do have examples here and there if you look at documentation, the repo that I showed you, and we also have a few blogs.
Awesome. And Federica, I know that this module is still in beta, and there's a lot that we still plan to add to it. But I want to kind of put you on the spot here. I want to take a look at the console one more time. Let's see if we can dig into some of the maybe monitoring, observability features that are in VPC Lattice. Do you think we can take a second and dive into that?
Yes, it's not actually configured in here, but just let me see through the to the console. So if you see here, we are looking at the service. So again, this unit of applications that we are using, and it's not enabled for the sake of simplicity, but you can see here there are some tabs that are relevant to what we were discussing, not only routing, but also access that would be an auth policies that you can add, an identity and access policy based one. We do have also monitoring. For example, when we are talking about monitoring, we are monitoring about the traffic layer 7 monitoring. So for example, you can have things like the total of connections, total error count to really troubleshoot your application and understand when problems lies or performance, how the performance is within your microservices application. And the nice thing is that you do have, again, this common interface, this common service that does this for you automatically if configured. And two, you don't really have to correlate this across accounts, across VPCs, across different compute environments, so different loggings, different ways to give security, because you're using a common service. And VPC Lattice can be also used across to connect applications across VPCs, for example.
Yeah, and going back to what you said earlier about the roles that individuals have within organizations, it also allows for abstraction, right? Because in a realistic environment, you might have one dev team responsible for a service, let's say running in Lambda, maybe another team responsible for running a service in Amazon EKS. At the end of the day, the app developers really don't want to know more about Kubernetes and the underlying infrastructure than they have to. So what VPC Lattice is really allowing you to do is abstract away those underlying components. You can represent a very complex application as just, a DNS name, and then you pass that between teams. I think that's really the idea behind this level of service networking and abstraction of the application layer, allowing businesses to kind of work more efficiently, right?
That's correct. Absolutely. And just one more thing that I wanted to say. Again, we said this a couple of times, but this module currently is in beta. So we do have a cleanup section. Please do run the cleanup if you want to move forward with other sections of the workshop, because otherwise this is not embedded. And actually, this was a decision that we made to do so because we wanted really you to feel the experience, also to see how easy it is to actually install the controller that we built and have a look at it and play with it. But since this service is relatively new now, moving forward with months, etc., we will be embedding this part within the core templates for EKS workshop. So also the cleanup part, which is related actually to this part, will be embedded and we will be graduating this module to version 1.
Excellent, excellent. Well, Federica, I just wanted to ask before we close our episode for today, is there anything else that you want to share with our audience for folks that are getting started with EKS or VPC Lattice? Any resources that you want to share with them, or what they can do to get involved with potentially the open source projects in the community as well?
Yeah, I think the most important part, if you wanna get started with this, is to go to this repo. We do actually, I just said that this exists, but we do actually have a dedicated folder with a couple of examples on how to get started. And we also have a rendered page for this, so maybe this is also another link that we could share.
Mhm.
And yeah, I think playing with it a little bit, it's really interesting. Also, the use case of the cross cluster. We are using let's say, an extended Kubernetes specification and another set of APIs that are usually used in conjunction with the Kubernetes Gateway API. And this is actually becoming a standard. And I think it's pretty fun to see how easy it is to connect clusters together and microservices hosted in different clusters with VPC Lattice without really the need to create a service mesh and manage all the fit of the cycle proxies. And even before thinking about that, have transit gateway and all these networking stuff is abstracted for you by VPC Lattice.
Awesome. And Federica, how can folks get in touch with you? Do you want to share maybe your LinkedIn, or what's the best way to get involved?
Yeah, absolutely. I will be available to answer your questions in LinkedIn, but also you can get in touch also in Twitter. And yeah, I think those are the two most common platforms that you can see me active on.
Okay, awesome. I'll make sure I have her Twitter in the description below. Federica, I have to thank you so much for two things, actually. Not only for coming on today and for the excellent overview of using VPC Lattice with Amazon EKS, but also for your contribution in developing that module in EKS Workshop. So thank you so much. Thank you for coming on the show. For our folks watching at home, drop a comment below. Let us know what your use case is with VPC Lattice, or let us know what you want to feature on Containers from the Couch next. I know we've done a lot of video series so far in the workshop, still plenty to come. Please let us know what you think and leave us feedback below. Federica, again, thank you so much for coming on the show. And for our viewers back home, be sure to subscribe, and we'll catch you next time. Bye now.